Resource management. In this module, you're expected to learn about the different vSphere resources management techniques. I would start off by discussing memory over commitment technique. This would be followed by a discussion on the various memory reclamation methods. Finally, I'll discuss shares, limits, reservations, and resource pools. And then we'll go to our vSphere web client and configure shares, limits, reservation, and our resource pools. So let's get started here. Memory over commitment. So memory over commitment, it is a process by which we allow our host to allocate to our VM more memory than it actually have physically. Okay, so once we overcommit our memory, the VM kernel uses several techniques to manage VM memory usage. Techniques like reallocating memory from less loaded VMs to higher workload VMs. So the extra memory on a VM, it is configured in a swap file. That's the .vswp file. So when the host memory is overcommitted, or when we are overcommitting our host memory, memory is basically swapped from this file to this. And generally, reading or writing to this is a lot less slower than if we were reading or writing to our physical memory. Okay, so let's have a look at the different methods we have. The VM kernel uses a number of methods to reclaim memory from the ESXi host. Firstly, there is a transparent page sharing, or TPS. So transparent page sharing, this allows for identical contents to be stored only once in memory. So typically, the results of this would be seen if you were comparing a similar workload on physical servers and not virtual machines. We would find that our VM consumes less memory than if running on physical servers. So the effect of TPS basically is it would allow our host to support higher level of overcommitment of our resources during period of contention for those resources. Secondly, we have ballooning. This is where the VM kernel reclaims idle or unused memory from a virtual machine. And this is done utilizing the memory balloon driver. Okay, so the memory balloon driver, this is installed when we would have installed VMware tools. And how this works is the balloon would inflate to capture idle or unused memory from the VM, and it would pass it over to the VM kernel to be allocated to other virtual machines. The VM kernel can also allocate back that memory to this particular VM should the need arise. And it does this by deflating the balloon for that VM. The third method of memory reclamation we have is memory compression. So memory compression, this attempts to reclaim memory by compressing pages of memory during memory contention. It does this to avoid the VM swapping out of its memory to the swap file. The fourth method we have for memory reclamation is creation of a host cache on a SSD device on our host. So this cache will be used after the other memory reclamation methods have been tried. So after we would have tried TPS, ballooning, and memory compression, only then would the VM kernel attempt to use the host cache on a SSD. The final memory reclamation method we have is to page is to page the VM memory out to disk. So this would be used only after the other methods of reclaiming memory are unable to reclaim memory from the host. Only then would this method be used. Paging would be the last resort due to performance penalty it places on the disk, as well as the fact that reading and writing to disk is a lot slower than reading and writing to memory. What we should also note is these methods, they would only be used during a contention for resources. Okay. So due to the fact that multiple virtual machines would be utilizing the resources on the ESXi host, resource contention would generally happen. And we have three ways of dealing with this. The first one is shares. So shares are relative priority or importance of access to resources that the virtual machine is given. It basically guarantees a virtual machine would have a certain amount of CPU, RAM, storage I/O, or network I/O resources. So during contention for resources, the share value can be modified. This can be modified whilst the virtual machine is running. Okay, so once a virtual machine is powered off on a host, the remaining virtual machines would have more access to resources since there are fewer total shares on that host. So shares are also used to compete within the range between the reservation and limits. So that range between your reservation and limits, that's where share would be competing. And we'll cover limits next, and then reservation. Limit is the maximum amount of CPU cycles or physical memory on a host that a virtual machine can use. Okay, so we'll get into the demonstration of how we could configure these and also how we could configure shares, limits, and reservation on a resource pool. Next, we have our reservations. So reservations, these are basically guaranteed value for CPU or memory resources that should be available to a virtual machine for it to power on. So a reservation guarantees a certain amount of performance for a virtual machine, which may require this amount to run properly, that VM. So rather than managing the resources individually for each virtual machine, we could combine the VMs with similar resource needs and characteristics. We could combine those into logical containers, and these would be called resource pools. So resource pools would be used to aggregate these resources. So if we were to go into our resource setting for a virtual machine, we could manually configure our shares, our limits, our reservation, or we could just create a logical container called a resource pool, and then grant it a certain amount of shares, limits, or reservation, and then drop our VM into that. And these resource pools could be created at different levels. It could be created on the individual ESXi host level, or it could be created on the cluster level. We could also use our logical containers, our resource pools, We could also use that to delegate privileges to users and groups. Also, VApps. We would have covered VApps in our introduction course. VApps can be considered as a form of resource pools for managing our VM resources also. We have what is called also an expandable reservation. So an expandable reservation is where a resource pool is allowed to gather resources from a parent resource pool when it can satisfy a reservation request. Okay, so we'll have a look at this once we start to create our resource pool in a little bit. What should be noted too is our cluster object under our data center. That cluster object that we drag our host into, it is considered a hidden resource pool. It's not listed as a resource pool, but it's considered as the root resource pool. Since it is basically grouping our resources too. You would want to be careful to use resource pools only when necessary, since it can cause unnecessary complexities in your infrastructure, especially if you are creating multiple child resource pools within a parent resource pool. Also, we should use resource pools for resource management, like we are discussing here, and not for grouping of our VMs. For grouping of VMs, we should use our folder in our inventory and not resource pool, because that just add additional layers of complexity and would cause issues if you're trying to troubleshoot a problem within your infrastructure. So you'd want to keep it simple and just create folder structures for organizing your VMs and just keep resource pools for managing of your resources. So let me pull up my vSphere web client here, and then we could have a look at this. So let's start by identifying shares, limits, and reservations, where we'll configure those. So if we go into our VM and templates view here, and let's just go into one of our virtual machine here. If I was to right click this VM here, I have the option here of doing editing the resource settings. So if I select that, right click the VM, then edit resource settings. Okay, so here we have the options of modifying our resource settings for this particular VM. Okay, so if I wanted this VM to have a low share on CPU, I could select that here. Okay, if I need this to be high, or I just need this to be a custom value, I could enter that manually here. If you notice, if you select low here, the share would change to 500. Okay, normal it's 1,000, high it's 2,000. Okay, for reservation, I could enter my reservation value here. Okay, so if I need to reserve, let's say 1 gig of this CPU, all right, I could enter that in here. Limit, if I need to limit this DSL virtual machine to only use 500 megahertz, let's say 500 megahertz for example, of the CPU, I could enter in that value there. And it's the same for memory here. So this is CPU, okay, and then we have our memory here. Memory shares, we could enter this in here, select a value, or just do a custom value for our shares. And the same goes for reservation and our limits here. Okay, We could also reserve all of the guest memory that this particular VM have installed, which is 128 megs. Okay, so we could reserve that entire 128 megs for this VM, so it would not be competing for the memory. Okay, I'll go ahead and just cancel this out here. As I mentioned, we could deploy our resource pool directly on ESXi host or on at the cluster level, sorry. So rather than configuring the shares, limits, and reservation at the virtual machine level, we could configure that for similar VMs. We could configure a resource pool and drag those VMs or move those VMs into that resource pool. So let's go over to our host and cluster view. All right. So at the cluster level here, I'll go ahead and create a resource pool. So let's say we are creating two resource pool, one for production servers, and then we are creating a second resource pool for our testing servers. And maybe we have a large testing environment. We need to create child resource pool within testing. So let's go ahead and create a couple resource pools here. So I right click on their cluster, new resource pool. Okay, and let's just give this a name. Let's call this production. All right. And say for production from memory. All right. For memory, I need to give this a high share value here. Okay. So I change the share to high for memory for production resource pool. And let me just hit on OK there. And let's say for testing, we need that to have a normal share on memory. So we have our production resource pool created here, but let's create the testing and then we'll come back to viewing the properties of these. Let's just go ahead, create a new resource pool. Okay, and let's call this one testing. And for testing, I need my memory share to be normal, so I leave this to the default. Okay. Okay, so now I have my two resource pools here. I have production and then I have testing. All right. Production, if I was to go under related objects, I have no virtual machine currently assigned to this resource pool here. All right. And that would be the same for testing. So actually, let's move a virtual machine to that production resource pool. So rather than editing the resource settings for this VM and directly, we're just move this into the production resource pool. So if I go here, move to, and I need to move the DSL server. I need to move this to, we're working on data center 1, the cluster 1. Okay, so notice over on the left, this resource pool it's all created under cluster 1 here. Since I have a few different clusters here. So I want DSL to go under production. And I'll select OK there. So now if I select this resource pool, go to a related object, you'll notice I have one virtual machine currently assigned to this resource pool. We could do the same. Say we needed to move DSL3 into testing. Move to. Let's go to our cluster settings. our cluster here, sorry, and we need to move this to testing. So at the testing level, we have a virtual machine in here. What we could also do is create additional resource pool within this. So we can have a child resource pool within one of these resource pool here. As I mentioned too, the cluster up here, this is a hidden resource pool since it's also aggregating our resources. So this is a parent resource pool. What we could do now is create a child resource pool. So let's do that actually. Let's create within testing. I want to call this test group 1. Okay. Let's just call this test group 1, and we could modify our settings here as needed. And let's create a second one here. Okay, so you guys see the structure here now. So let's create another one here. And we'll call this test group 2. Okay, we could modify our settings here. Then hit on OK here. Okay, so now we have our root resource pool, which is the cluster. We have our parent resource pool here. Okay, we have 2 of them, and then within the testing parent resource pool, we have 2 child resource pools here. The relationship between test group 1 and test group 2, these would be siblings. Okay, so test group 1 and test group 2 there. Okay, and if we go into the related objects for testing resource pool, we'll now see that we have test group 1, test group 2, and it contains only one virtual machine. Okay, so we could go ahead and set up our infrastructure here to manage our resources. But as I mentioned, you wouldn't want to use resource pool to group your resources. Okay, only for resource management you would want to create resource pool. Ideally, you would want to create folders for your VM and stuff like that to organize it in your inventory here, and not use resource pool for doing that.